All right, we'll begin with question numbers 4 and 5. Prove that the tangents drawn at the end of a diameter are parallel. First, let's look at question number 4. Okay, ignore 5 for now. Question number 4 may prove that the tangents drawn at the end of a diameter are parallel. For that, we need a circle and we need a diameter already in that circle. Okay, so let's draw a diameter. This is my diameter. Okay, it's passing through the center of. Now the tangents drawn at the end of the diameter are parallel. Think about it. If I'm drawing a tangent here, it'll look like this, right? End of the diameter means this point. Let AB be the diameter, this point, and this point, right? Now, to prove any two things are parallel, prove any two lines are parallel, what do we need? What do we need? We need any of the angles situation, like alternate interior angles or corresponding angles, or sum of interior angles on one side of the transversal is 180-degree. We need alternate interior angles are equal. You can use any one of them. Okay. If you see, this is 90-degree because the radius at the point of contact is perpendicular to the tangent. This is also 90-degree because the radius at the point of contact is perpendicular to the tangent. And these two angles are alternate interior angles to each other. So they are equal, and they are equal. Hence, these two lines, L and M, are parallel. Can I get a fistify in the chat box quickly about this discussion? It's a very simple one-step proof. Fistify in the chat box about this discussion. Okay. All right. Asgar, rewatch it later. Yeah. So these two, there are two lines here. These two are tangents. For any two lines to be parallel, we need to do any one of these. Either we can show alternate interior angles are equal. We show that, then it's parallel. We can show these when we add these two interior angles on the same side of the transversal, it's 180-degree. That also will happen. We show that, then also we can say it's done. Okay. So moving on to question number 5 now. Prove that the perpendicular to the tangent at the point of contact of a tangent to a circle passes through the center. This is a very, I don't know, I don't feel like this, I'm a little confused about this question, but I'll just run you through it. Okay. Prove that the perpendicular at the point of contact to the tangent. Okay. So there is a tangent. They're saying if we draw a perpendicular at the point of contact here, this is a point of contact. Okay. They're saying if we draw a perpendicular at the point of contact M here, so we are drawing a perpendicular. Okay. This perpendicular will pass through the center is what we have to prove. Will pass through O. We don't know whether it will pass through or not, they're saying, and we have to prove that it will pass through O. See, we already know that given is what? Let me make this longer. Let this be X and Y. Okay. XY is perpendicular to, let this be PQ. PQ at M, and PQ is a tangent. Okay. Now O we are marking here. Okay, just assume that it is not passing through center. Okay, they are saying because we have to prove that it will pass through center. No, prove that perpendicular will pass through the center. Okay, prove that the perpendicular will pass through the center. So my to prove is you can say my to prove is O will lie on XY. Okay, that's my to prove. Take a minute to absorb this and give me a fistify in the chat box if this is clear. If the given and to prove is clear. Hey Manisha, go ahead.
So can we say O is the center point of it?
Correct. That should be in given, right? Very good, Manisha. Good point. O is the center of the circle.
Sir, no,
Perfect.
sir. That should be
Mhm.
to prove. No, sir. We have to prove that.
No, center of the circle. Uh, to prove is what, Manisha? Like we know that O is the center of the circle. We don't know whether O is on XY or not. Are you understanding? They are asking us to
Um,
show that O is so XY is passing through O. Or we can write like this also. We can write like this: XY is passing through O. Understanding?
yes, sir.
Okay. O is the center, that we are just assuming that O will be the center. Okay.
Yes, sir.
All right with this. Now, let's see. Okay. Everyone is at 5 here. Okay. So now for a minute, so this is again, I think it's going to be proved by contradiction probably, or something similar to that. So for a minute, think that let let's assume that O is uh, not lying on XY. Okay. Okay. We good with it? Uh, draw draw a perpendicular from O to PQ. Okay, you're drawing a perpendicular from O to PQ now. Assuming that O is not lying on XY, you draw another perpendicular. Okay, let's call it ON. Okay, let's call it draw perpendicular ON. Draw perpendicular ON from O to XY, from O to PQ. Okay, now think about this, guys. When we are drawing a perpendicular from the center to the tangent, we know that will be the radius, right? And it will be touching at the point of contact. We already know that, right? That it will be the radius and it will be touching at the point of contact. Now, uh, if ON is perpendicular to PQ, then N ON should be the radius. Wait, and PQ is tangent. Okay, and PQ is tangent, is a tangent to the circle, then ON should be the radius and N should be the point of contact. Are we getting this? It cannot be something else. Okay, this perpendicular should be the radius and it should be the point of N should be the point of contact, which means basically N and M have the same points. I'm not sure if I explained properly. How are you guys feeling about this? Anyone else? Riza has given me a thumbs up. Anyone else? MG is clear. Okay. All right. So N should be the point of contact. That is, N and M should be the same point, right? That's one way of looking at it. Now, if N and M have to be the same point, uh, we can only draw one perpendicular at one point, right? We cannot draw more than one perpendiculars at one point. Okay. This implies that uh, the perpendicular at M will pass through O. Are you understanding? Ulta we are going. Therefore, our assumption is wrong. Okay, our assumption that O is not lying on XY is wrong because the perpendicular will pass through O. Therefore, O will lie on XY, or we can say that XY is passing through O. Okay, therefore XY is passing through O. How are you feeling about it? I'll go ahead. Riza, go ahead.
Sir, N and M should be the same point because the tangent will have only one point. So no, sir. And that tangent can pass through.
Good. I like this addition, Riza, that you're doing. That a tangent can only have. So the reason here it can be that a tangent can only have one point of contact, right? A tangent only has one point of contact. That's by definition of a tangent. You're right, Riza. Okay. Any other thoughts here? Dinesh, how are you feeling now? Dinesh, you want me to repeat again?
No, sir. Clear, sir.
Clear? Okay. All right, take a screenshot, please. I'm not having WhatsApp, so please take a screenshot and put it in there. Bindu, I'm sorry, I don't think I'll be able to repeat because it will take away time. You will have to watch the video later. Okay? We're moving ahead. Now, question number 4 and 5 we're done. Okay, moving on to question number 7. Guys, someone put a screenshot, right? Did someone put a screenshot?
Yes, sir. I have.
Thank you, G. Next question is, this is question number 7. This is a very good question. This question, so I've not gone through the circles chapter paper, but it's a very commonly asked question in board exams generally. Okay, I've seen this in a few papers long back, but I'll just tell you. So pay very good attention. Yeah, two circles of radii 5 centimeter and 3 centimeter are concentric. So I have to make two concentric circles. Okay, now this is one circle, and there is another. We had one other question earlier, no? You know what's concentric circles? So there is two circles. The radii of one of them is 3 centimeter, and this one is 3 centimeter, and the bigger one is 5 centimeter. Okay. So they're saying find the length of the chord of the larger circle which touches the smaller circle. It's very similar to the one of the questions which we have done earlier. I think it was an example question. Yeah, example 1, you remember? Only there we were proving something. Here we have the same diagram essentially. So there is a chord here. There will be many chords here, of course, which will touch the inner circle. So this is chord for bigger circle, but tangent for smaller circle. Okay. So AB is chord for bigger circle, but tangent for smaller circle. They're saying us find the length of this chord. Okay, find the length of AB. Okay. So what we have to find AB length is what? Okay, or it will be many chords will be there like that, but mostly all of their lengths will be same. Okay, if not mostly, all of their lengths will be same because these two circles are concentric. So equidistant. So you think about it, equal chords are equidistant from the center. So all these tangents to the smaller circle will be equidistant for the bigger circle, right? Will be equidistant from chords for the bigger circle. So any one of them we have to find the length of. Okay. Take a minute if you're understanding what I just told about the question. Can I get a Fistify in the chat box? If you're understanding what the question is saying and what I just told about, like there can be many chords like this, all of them will have the same length. Why will they have the same length? Because equal chords of the bigger circle are equidistant from the center, and distance from the center will be same because they are tangents to the inner circle of 3 centimeters. Okay, stay with me here. All right, I'm just going to complete this diagram a little bit. Okay, look at this diagram like this. Okay, I'm going to draw this radius. Okay, let's call this M, and I'm going to draw this big circle's radius. Okay, let this be O only. This is 90 degree. Okay, now if you notice very carefully, this is 90 degree wide. So what I'm doing is I'm joining OM, joining O with AB at the point of contact. Okay, at point of contact M. We are okay with this? Join O with AB at the point of contact M. Now what is this? What does this lead to? Okay, therefore we get OM will be perpendicular to AB. Okay, also join OB. Okay, now once you do this, see triangle OMB is a right triangle. All right, now in this right triangle, I want to start thinking, what is the length of OM? What is the length of OM? Can someone tell me? Manisha, go ahead.
Sir, 3, sir.
3 centimeter, fantastic. Can someone tell me? Dinesh, can you tell me what is this length of OB?
5, sir.
5, sir. Fantastic. So you have 3, you have 5. Can you find MB? Can you find MB? So OM square plus MB square is equal to OB square. There will be 3 square plus MB square will be equal to 5 square. Obviously, you know the answer already. It's a Pythagorean triplet, the most common Pythagorean triplet. So you'll have MB equal to 4 centimeter. Okay, but the answer is not yet done. We have to find the length of the chord. We have to find full AB. How do we find that? We only know that MB is equal to 4 centimeter now. How will we find AB? Anyone? Which circle we are going to use? Go ahead, Riza. Which circle we are going to use and what's your logic?
Sir, I was thinking we'll repeat the same thing after joining AO, sir.
Too much work, no? Can you make it like, is there a quicker logic, Riza? We can do that also. Yeah, people have already typed in the chat box. Manisha and Dinesh have typed it in the chat box. Riza, Manisha, Dinesh, can you give the reason? I need the reason. Why are you saying 2 into 4? Why? What's your reason? Manisha, you can speak.
Sir, perpendicular of a chord will cut it into half, sir.
Perfect, perfect. Riza, remember this theorem?
Yes, sir, got it.
Perpendicular, so we are seeing bigger circle now. Okay, we're seeing bigger circle. This is a chord perpendicular to the chord from the center, bisects it into 2. Therefore, I have AB is equal to 2 into MB as perpendicular from center bisects the chord. Okay. Here we are thinking about bigger circle. Okay. I'm just writing this here so that it's clearer. So AB is equal to 4 into 2. That's equal to 8 centimeter. How are you feeling? This is a very common question in board exams. This is a very interesting question. Yes, Bindu. Guys, take a screenshot. Bindu, go ahead. What's going on in your mind?
Sir, what Riza said is also correct, no, sir.
Riza said is perfectly correct. It's just longer. Okay. So I encourage you to think in a quicker way. Yeah. If this does not strike your mind and you end up doing the way like Riza suggested, no problem at all. Okay, Bindu? It's completely right. Yeah. All right. So we are done with question number 7. We're going to question number 9 now. Okay. 9 is a little interesting question. Last class, has screenshot been shared already?
Yes, sir.
Thank you, G. 9th question is something which we struggled with in the last class. I was also stuck and it did not strike me very quickly, but actually, like after spending a little time thinking about it, it's like a novel question. Okay, you need like to spend time thinking about it. It's a thinking type question. Let's or that's what happened with me. Let's see how I think we can do it, and we'll run through it. Yeah. So this is the figure. Okay, this is the figure that they put up. They're saying that xy and x dash y dash are parallel tangents to the center O. Okay, and another tangent AB with point of contact C. So there is this AB is here. Okay, one second. Give me another color. AB is here, and that AB is touching C here. Okay, touching the circle at C, which such that A is lying on this parallel tangent and B is lying on this parallel tangent. Okay, but what? So let's write down what's given. Okay, let's write down what's given and break this down. Okay, given is xy is parallel to x dash y dash, and they are tangents to the circle. All right, that's one thing. And the next thing that's given is AB is another tangent with point of contact C, such that no need of writing such that, you can directly write A lies on xy, A lies on xy, and B lies on x dash y dash. Okay, so this is a line, so I'm putting this symbol. If you just write xy, since it's also line segment, it's fine, but it's fine. Yeah. So moving on to the proof part, no, to proof part. Okay, what do we have to prove? We have to prove that angle AOB is equal to 90 degree. Okay, and I wanted to take your attention to this particular triangle, not to the triangle, but to the particular angle. Which angle they're talking about? They're talking about AOB. It already looks 90, but we have to prove that this is 90 degree. Okay, that's our to prove part. Now, my mind is going, why have they mentioned point of contact C at all? Okay, why have they mentioned point of contact C at all? And I'm thinking, is that going to hold some relevance in my answer? And just so my brain is so maybe I'm thinking that maybe let's see what can we do with C. One simple thing I can do is join this. No, that's one simple thing. Maybe that will give me some hint. Okay, now when I join this, I start seeing that I'm getting a few triangles here. I'm getting this triangle and this triangle, and I'm also getting these two triangles, this triangle and this triangle. Okay, let's see. It's a little tricky type of a question, but maybe we'll have to do it a few times to be like sure of it. One or two times we'll have to do it. I've not seen this type of question circles chapter here, or even in like other books. It's a little different, but let's see. So let's see what happens. Okay, now Bindu is not exactly perpendicular bisector. Maybe AC is longer than BC. We don't know. Okay, this is not a chord. No, Bindu. This is a tangent. Bindu, are you understanding? This is
Sir,
perpendicular.
Last question, sir, not this question.
Oh, okay. Sorry. All right. But it came only at 9:30, so I thought you just sent it. Okay, no problem. So right now you're saying we can join this one. You're saying, right? So when I join this, okay. Now we are also seeing, yes, Nishchay, very good observation. AC is equal to AO nahi hoga yaar. AC is equal to what? BO is not the tangent, Nishchay. What is the tangent from A? What are the two tangents from A? Think about it, Nishchay. From A, AC and one more is what, Nishchay? AP. Yes, AC and AP are the tangent. Okay. Just like that, BC and BQ are the tangent. Okay. Tangents. Now you see this particular two triangles, AC and AP, OA is common with OA, and OP and OC. So this triangle is congruent to this triangle. Can we see that? Do we see that? Guys, triangle APO is congruent to triangle ACO. Okay, that's something which I'm seeing. Okay, let's see if this helps us or not. Same way, this triangle is similarly, this triangle is congruent to this triangle. If you see BQBC equal, OQOC equal, and OB and OB equal. Okay, So let's see if that helps us in any way. Okay. Let's see if that helps us in any way. Okay. Let's first write that part. If that helps us in any way, we'll see. Yeah. Okay. What's going on here? Everything is moving. Yes. So let's get to the proof. Okay. And then we will pick up from there. Okay. So we can show that triangle APO is, first we are doing what? Join OC we are doing, and we're saying triangle APO is congruent to triangle ACO. You have to write the steps. Okay. You have to write the steps, you have to give the reason, and you have to write the steps. This you will get by triple S. Okay. Similarly, you will get triangle BCO is congruent to triangle BQO. Everyone okay with this? By triple S again. Is everyone okay with these two congruency things? Can I get a fistify in the chat box? You will be able to write the steps here. I'll just write and keep write complete steps. Okay, to show the proof. Will you be able to write the steps and you'll be able to get here? Then we'll see what happens. Yeah. All right. I'm getting a 5. Asghar, how are you feeling here? Are you confused? No response from you. Shripriya, can I get a check quickly? Guys, I know we are not in school right now. I know it's a little difficult to concentrate on online classes when we are at home, but we have no choice right now. If there is no way we can wait till the school starts, because there's a lot to cover. Yeah. So I'll need you to force yourself to be attentive in class, right? Okay. It's counting on your attention. I have no way of making sure that you pay attention. So it's your responsibility. Now join O. So this now from this congruence thing. Okay. Now remember, what is my final goal? Final goal is to find this angle. Okay. Final goal is to prove that this angle is 90 degrees. Now if you see, by CPCT, I'm getting that this angle and this angle are equal. Okay. From first ones by CPCT, I'm getting this angle and this angle equal. From seconds one CPCT, I'm getting this angle and this angle are equal. Okay, stay with me there. Yeah, everyone okay with this? So I'm going to just label these angles a little bit so that it becomes, quicker to talk about them. Let's call this A, B, everything they've used. P, Q also they've used. X, Y also they've used. Let's call it U, V, W, and Z. Okay, U, V, W, and Z. Okay. Now, if you notice, from by CPCT, from this one, okay, by CPCT, we will get angle U is equal to angle V. Okay. And by CPCT of this one, we will get angle W. We will write angle Z is equal to angle W. Everyone okay with this also? Guys, give me a thumbs up if you're okay with this. Can I get a thumbs up on screen? Quick thumbs up on screen if you're clear with this. All right. Now what I'm thinking is all of this is fine. Okay. We've already reached how much we have to. We've reached close to the angle. But what do we know about this whole angle? Do we know anything about this whole angle? We can do do we know anything about these angles, which will help us manipulate, which will help us go something ahead? Dinesh, you're saying it's 180 degree. Dinesh, can you tell me what your reason will be? Why do you think this is 180 degree? Dinesh, you're right. Let me tell you. Okay. Firstly, let me tell you that you're right. But I want to understand what is your reason that this will be 180 degree. Why is it a straight line, Nishchay? Please answer that question. Why can I not think that OP is like this, OQ is like this? Why is it a straight line, Nishchay? Why do you think it's 180 degree? That's the reason. Okay. Manisha, why? Manisha, can I get that? Okay. Riza, go ahead. Yes,
Sir,
Dinesh, you want to speak? Dinesh,
Sir,
you want to speak? Let
X,
him try once, otherwise I'll come to you, Riza. Yeah.
sir, X, Y, and X dash and Y dash are parallel, sir.
Okay.
Sir,
So,
the perpendicular drawn will be like diameter, no, sir.
okay.
So the PQ is a straight line, no, sir. So 180 degree.
Perfect. Perfect. Riza, are you satisfied with Dinesh's explanation? You want to add something here?
yes, no, sir, same.
Great. So I'm going to give Dinesh here 5 points. Very good, Dinesh. And yeah, this was good. I love that you thought through it. Okay. Now we know that. So we're going to do that. Okay. First, we have to show that angle POQ is 180 degree. To show that it is a straight line, you have to first show that it is diameter. PQ is diameter. So for that, we know that XY is parallel to X dash Y dash. Therefore, PQ is diameter. Okay. As lines, what is that? Tangents parallel to as what would the reason be? Riza, can you help me with the reason?
So because so it will be long, no, sir, because OQ will be perpendicular to
Correct,
XY
correct.
and OP will be perpendicular to
We have to write all of that, right?
yes, sir.
So let's write that. Okay, Dinesh, go ahead. Tell me. So XY is parallel to X dash Y dash. Okay. We also know that OP will be perpendicular to XY and OQ will be perpendicular to X dash Y dash. But it's okay. Therefore, PQ. Manisha, go ahead.
So can we just say PQ is passing through center of circle?
PQ is.
So
There's a
it
lot
is
of TV
passing.
noise or something coming from behind you. Can you move to some other place and tell me? PQ is what you are saying we should say?
Sir, it is passing through center, no, sir. So can we say it is diameter there?
Correct, correct. No, it is not enough, Manisha, because I can have OP here and OQ here. No, it's still passing through center. No, PQ, but it should be like we should show that it is on a straight line, right? Then only we say that it is a diameter, right? So actually, we can use that logic. Okay, chords, the tangents at the end of a diameter are parallel to each other. I think that should be enough. You remember we have talked about that earlier.
Yes, sir.
So tangent. So here PQ will be diameter. Will be the diameter. We have talked about this. We have already seen this. I think axiom probably because we have not proved this theorem. Tangents at the ends of a diameter are parallel to each other. Good with this, Riza and Dinesh?
Yes, sir.
Yeah.
Yes, sir.
Tangents at the end of a diameter are parallel to each other. Hence, now XY is parallel to X dash Y dash, we know. So PQ will be the diameter. Okay. Now stay with me here. If PQ is the diameter, therefore we say that angle POQ, therefore angle POQ is equal to 180 degree. Okay, because PQ is a diameter means it's a line segment. So angle POQ will be 180 degree as PQ is a straight line. Okay, PQ. One second. PQ is a straight line segment. Okay. Now, therefore, we come to the point that angle U plus angle V plus angle W plus angle Z is equal to 180 degree. Can you see this? Angle U plus angle V plus angle W plus angle Z will be 180 degree because it is a straight line. PQ is a straight line because PQ is the diameter, which means angle U plus, sorry, let's remove. What do we need finally? What do we need? We need V and W. We need V and W because U and V we don't need. We need to show that this angle is 90 degree, right? So let's put V and W only. So in place of U, we can put V. So you'll write angle V plus angle V. And in place of Z, we can put W. So plus angle W plus angle W is equal to 180 degree. That means 2 times angle V plus angle W is equal to 180 degree. Bindu, you're okay with this manipulation? I skipped a step here. Angle V plus angle W is equal to 90 degree. That means angle V plus angle W is what? Angle AOB. That's our to prove part. Angle AOB is equal to 90 degree. Hence proved. Dikshit, how are you feeling?
Understood.
Understood. Bindu, can I get a response? Can I get a fist to find the chat box? And the screen is available here for a screenshot to be taken. Okay. All right. A little tricky, like this particular part of like was a little tricky, but I'm like it's yeah, I'm also not like completely convinced with like the steps with like this particular thing, but I think it will fetch your marks. Yeah, maybe we can go into more details and go the way Dinesh and Riza were going, but I feel that's it's okay if you do it this way also. Yeah. All right, take a screenshot, share. Let's move ahead. I understand, Dikshit. Okay. All right. So now we are going to move on to the. Everyone ready to move ahead? Tell me if you want me to stop. Okay. Now we're going to move on to the question number 11. Okay. Prove that the parallelogram circumscribing a circle is a rhombus. It's a very, very good question. Okay. Parallelogram circumscribing. What is circumscribing? We've seen already. Okay. So there is a circle. Okay. Let me make it a different color. Dikshit, go ahead. Dikshit, you're raising your hands. Go ahead.
All the vertices of the parallelogram lies inside a circle.
No. Ulta, Dikshit. Okay. Parallelogram is circumscribing the circle. Okay. We saw yesterday quadrilateral is circumscribing. Matlab, basically, we are having. This is my quadrilateral. Are you getting parallelogram? No, sorry. This is my quadrilateral, which means my quadrilateral is touching all 4 sides of the quadrilateral are touching the circle. Does that make sense?
Yes, sir.
Okay, let's not simply lies inside. So let's write this down. Let's write this down. Circumscribing ka meaning. Okay, circumscribing ka meaning is when a polygon circumscribes a circle, it means that all its sides are touching the circle. Basically, all its sides are touching means are tangential. Okay, are tangential to. That is, they are tangential to touching the circle. Does this make sense? Does this make it very clear, Dikshit? Yeah. Anything can circumscribe. A triangle can also circumscribe. A pentagon can also circumscribe a circle. Okay. Anything can circumscribe. So basically, all the sides should touch the circle. Okay. Now they're saying that it is a parallelogram which is circumscribing. They're not saying simply tangent. They're saying parallelogram. So let me draw parallelogram only. Okay. Let's see how it comes. So maybe it'll come. See if I move this here. Yeah, I got a parallelogram which is circumscribing the circle. Perfect diagram. Okay. Now for this parallelogram, they're telling us to, okay, it's not perfect, little here. There is a gap, but you get the picture, right? It should be tangential. Okay. We're saying prove that it is a rhombus. Okay, so let's name this parallelogram as A, B, C, D, and let's name the points of contact also as P, Q, M, and N. The center is O, our favorite center. Now we have to prove that this is a rhombus. Okay, remember that is already we know it's a parallelogram, which means we already know that this side and this side are equal. We already know that this side and this side are equal. Okay. For it to be rhombus, what extra we need to know? Anyone? If we want to show that it's a rhombus, what is the difference between a rhombus and a parallelogram? What do we need to show to make it a rhombus and not just a parallelogram? Hemanji?
So the opposite angles.
Bro, in a parallelogram also, if I just take a parallelogram also, opposite angles will be equal, no? That's from the parallelogram definition also we have that. Riza, what else do we need to know?
Sir, all sides are equal.
All sides are equal. That's what we need to know. Thank you, Riza, for remembering and reminding this to the class. I'll put 5 here. All sides are equal. That's what we have to show. We cannot just show that opposite sides are equal. That is in parallelogram also it happens. But in rhombus, all sides are equal, which means we have to show that AB is also equal to AD and BC is also equal to MD. Okay, if we do that much, that is enough. Another way of showing it's a rhombus is diagonals are intersecting at 90 degree. That's another way of showing it's a rhombus. Okay, that does not happen in a parallelogram. That may or may not happen in a parallelogram. Are we good? So these are the properties of a rhombus. So what we're going to do, we're going to wrap up the class here. Okay, we're going to wrap up the class here. I hope this question is clear for you. Okay, this will be one of the homework questions which you have to do by yourself. Okay, so let me run you through what all we have done so far. We have done question number 4, 5, 7, 9, and we were doing 11. Okay, so 11, question 11. So this is already done. Okay, you have to make notes of this. Tulsi, go ahead.